Okay, this is a perspective paper that's quite a bit of text. It's very long list of authors. So even if everybody added a few sentences, it would end up being as big as a book. But anyway, it's getting ready for the next assessment of IPCC. You know, we just had assessment report 6 come out in 21-22, delayed by COVID. Next one should be out in 28-29. You know, they have a 7-year cycle. So protocols for scenarios are developed, integrated assessment models are used to chart out emission pathways, and then they are fed into Earth system models to produce outcomes in terms of all the output that we look at, how the extremes will change, how sea level will rise, everything, lots of uncertainties, and I have my own opinions of where it should go next, but let's read what this group has to say. It says, bringing it all together, science priorities for improved understanding of Earth system change and to support international climate policy. I would say at this point, policy is we need action rather than policies, but nonetheless, we'll read the abstract because it gives a pretty clear picture of what they are talking about, and then we'll read some more text just to see what the details are. It's a bunch of diagnosis of what's been happening, what the shortcomings are, and how they can be closed, how uncertainties can be quantified, how everything can be made consistent with each other in terms of the multiple pieces that go into the assessments and so on. We review how the international modeling community encompassing integrated assessment models, global and regional Earth system and climate models and impact models has worked together. So the community has worked together over the past few decades to advance understanding of Earth system change and its impacts on society and the environment, and thereby support international climate policy. You can think of it as adaptation mitigation efforts, mitigation being global, adaptation, there are requirements on national adaptation plans, etc. We go on to recommend a number of priority research areas for the coming decade, a timescale that encompasses a number of newly starting international modeling activities, as well as the IPCC 7th Assessment Report and the 2nd UNFCCC Global Stocktake. So that's the United Nations Framework Convention on Climate Change. Global Stocktake is basically to track all the progress or lack thereof in the Paris agreements, let's say. Progress in Paris agreement and the commitments. Progress in these priority areas will significantly advance our understanding of Earth system change and its impacts, increasing the quality and utility of science support to climate policy. They keep saying climate policy. I wish they would say climate action. We emphasize the need for continued improvement in our understanding of and ability to simulate the coupled Earth system and the impacts of Earth system change. There is an urgent need to investigate plausible pathways and emission scenarios that realize the Paris climate targets, for example, pathways that overshoot 1.5 or 2 degrees C global warming, before returning to these levels at some later date. Earth system models need to be capable of thoroughly assessing such warming overshoots, in particular the efficacy of mitigation measures such as negative CO2 emissions in reducing atmospheric CO2 and driving global cooling. Okay, the idea of 1.5 and 2 degrees C that came out of Paris Agreement, they themselves have a lot to debate about. An improved assessment of the long-term consequences of stabilizing climate at 1.5 or 2 degrees C above pre-industrial temperatures is also required. I would agree that we would basically need to think about what the consequences will be at a very local scale for each 0.1 degree C warming above where we are, and that's not just in the global mean, but global mean 0.1 degree C, what does it mean for all the regions in the world in my backyard? Otherwise, we are providing information at scales that are not always useful, especially because after 1 or 2 decades, the later decades are completely dominated by the scenarios that are assumed, which are going to be tinkered with again for the next assessment, right? So we are running this cycle over and over again. It's not clear whether we really need another assessment or whether we have the range we need already so that we can focus on maybe decadal predictions or something. Okay, we recommend Earth system models run overshoot scenarios in CO2 emission mode to more fully represent coupled climate carbon cycle feedbacks, and wherever possible interactively simulate other key Earth system phenomena at risk of rapid change during overshoot. In other words, if you want to run full Earth system models with carbon cycle and the feedbacks, the resolution is often compromised because it becomes very expensive to run them. So the question then is, what do you want? You want local information, regional information, and how are you going to get it? Or you are going to make it as complex as possible and produce information at coarse resolution and then use Cordex and other ways that we will look at to produce local regional information, and whether this method works, right? Regional downscaling and impact models should use forcing data from these simulations. So impact and regional climate projections cover a more complete range of potential response to a warming overshoot. An accurate simulation of the observed historical record remains a fundamental requirement of models, as does accurate simulation of key metrics such as the effective climate sensitivity and the transient climate response to cumulative carbon emissions. So these are technically diagnostics. You can't really, you produce some simulations with increasing CO2 and other greenhouse gases, and then you diagnose how much it is warming for increasing, let's say, a ton of CO2, and you call it climate sensitivity. Climate sensitivity is typically thought of as an equilibrium calculation, but there is no equilibrium, so you call them transient climate response, and then there is no real way to verify what is the truth. For adaptation, a key demand is improved guidance on potential changes in climate extremes and the modes of variability these extremes develop within. So natural modes such as El Nino and La Nina and NAO and PDO and so on. Such improvements will most likely be realized through a combination of increased model resolution, improvement of key model parameterizations, and enhanced representation of important Earth system processes, combined with targeted use of new artificial intelligence and machine learning techniques. We propose a deeper collaboration across such efforts over the coming decade. So obviously it's a wish list that is quite long and honestly a bit of a kitchen sink, because you can list everything you want under this, right? With respect to sampling future uncertainty, increased collaboration between approaches that emphasize large model ensembles and those focused on statistical emulation is required. Again, just a list, because large ensembles are expected to give you a better sense of internal variability so that you can see what is really a trend above the natural or internal variability. So signal is the trend we will get because of the greenhouse gas increases, and noise is the internal variability. So you want to have a good sense of the noise by using methods like large ensembles. We recommend an increased focus on high impact, low likelihood or HIL outcomes, in particular the risk and consequences of exceeding critical tipping points during a warming overshoot and the potential impacts arising from this. So there are tipping points in the system. We talk about many of them: El Nino shifts, Arctic ice loss, Greenland glacier loss, let's say, and so on. And of course there is always the Atlantic meridional overturning collapse, which is not really happening, but many claims keep being made. For a comprehensive assessment of the impacts of the Earth system change, including impacts arising directly as a result of climate mitigation actions, it's important that spatially detailed, disaggregated information used to generate future scenarios in integrated assessment models be available for use in impact models. So have integrated assessment models to produce scenarios for the future for emissions pathways. So the representative concentration pathways, the last version of shared socioeconomic pathways, not sure what it will be called this time in assessment 7, and then you have impact models, and then you often use statistical models or climate emulators to derive a lot of the information. Conversely, there is a need to develop methods that enable potential societal responses to projected Earth system change to be incorporated into scenario development. Assuming you are going to keep doing this, whether it's really useful or not, then you have to worry about these things. If you decide that we have all the range of scenarios we need already, and we can focus on decadal predictions which can allow planning and strategizing for 1 or 2 decades, then we will go in a very different directions. The new models, simulations, data and scientific advances proposed in this article will not be possible without long-term development and maintenance of a robust, globally connected infrastructure ecosystem. This system must be easily accessible and usable by modeling communities across the world, allowing the global research community to be fully engaged in developing and delivering new scientific knowledge to support international climate policy. Well, I wrote an article recently after Trump came in and started slashing NOAA and other climate activities in the US, that maybe there is a global coordination needed to do the so-called case-scale modeling or 1 kilometer global modeling, which cannot be done by one country in a realistic sense. So we can develop a global coalition to do that. This is a similar argument, but in a climate scenario demand rather than climate predictions. I would say 1 kilometer scale doing weather, climate and decadal predictions will be much more exciting for me in terms of producing really local usable information. Okay, so let's read a few words on why they think this is needed. I've jumped ahead quite a bit of the text. With the new IPCC AR cycle assessment report cycle 7 beginning, it's timely to review how the international modeling community has supported climate policy in the past, including earlier AR cycles, and ask what advances can be made in the overall quality and availability of science to support policy needs. In addition, it's pertinent to review our current understanding of and ability to model coupled Earth system change, as well as the societal and environmental impacts associated with this change, and ask whether plausible, safe pathways can be developed for the Earth system that avoid the worst impacts of the change. Okay, so we'll just jump to table 1, because there are lots of details which are captured succinctly in the abstract in terms of the global technological infrastructure they imagine for everybody to participate and somehow make this a global exercise. Sounds nice, but exactly how this can happen is not clear. So there are other people who have written similar things, so this is not necessarily completely new in that sense, but doesn't mean it's redundant that people do bring this different perspectives. The paper basically has sections like this: provision of a coordinated, internally consistent set of simulations, data and knowledge to support IPCC assessments and international climate policy. Third section talks about improving knowledge and guidance on future Earth system change, allowable emissions, net zero responses and safe landing pathways for planet Earth. And within that you have the Paris Agreement, the risk of warming overshoot, allowable emissions, net zero and negative emissions, and Earth system feedbacks. 3.2 goes into regional Earth system change, so assessing societal and environmental impacts, which only make sense at regional and local levels and not at global levels. Improving our understanding of and ability to model key climate processes, climate variability, extreme events and regional impacts. That's section 4. Under that you have improving key phenomena and coupling in global climate models. So these are not really new ideas, in the sense we have been trying to improve key phenomena and couplings in the climate models for a while, but it still has to be listed. And then there are other details that will continue. Increased model resolution from global to regional scales for regional impact assessment and adaptation. They provide some ideas on how to do that, but people have been trying, and obviously computational power is a limitation. Idea of a case scale modeling would be that there will be 1 or 2 global efforts and not the infinite number of models that are being run now for assessment reports. Global storm resolving models and the path to global kilometer scale. So that's what I would argue is most exciting in terms of providing relevant spatial and temporal scales for decisions, disaster management as well as planning. Fifth one, increasing collaboration across approaches to improve global and regional Earth system and climate models. Improving model simulations of the observational record and key metrics of climate change so that you have a good sense of historical performance of the models before you go into the future with them. Especially in terms of internal variability, because the suite of models used, they do trends very well given the emissions, solar forcing, volcanoes, etc., but they are not able to do internal variability very well. Okay, I will say that and leave it there. But internal variable, so if you look at 7, sampling and quantifying future uncertainty includes internal variability. So let's read that a little bit. Multimodal ensemble projections such as those from CMIP and CORDEX. CORDEX is the Coordinated Regional Downscaling Experiment, where CMIP 6 global simulations are taken and run for specific regions at much higher resolutions, except they are often done without coupling to the ocean, so some things get worse, like the Indian monsoon. Global climate models, coupled models are doing something, then you take it and downscale with a prescribed sea surface temperature, then you get very different results, which is not really fun. Okay, so this also should include a sample a number of plausible integrated assessment model emissions and land use scenarios. The MMEs or multimodal ensembles often include a small number of ensemble members per individual model, each sampling interval variability as represented by that model. The MME approach to a limited extent also addresses structural modeling uncertainty. There are scenario uncertainties and structural model uncertainties. The degree to which this aspect of uncertainty is sampled is ultimately constrained by the resolution and process realism of the models involved, as well as by the degree of commonality of approaches to representing unresolved and uncertain model processes. There are a lot of details that you can follow up on with other papers. In that you have high impact, low likelihood outcomes, HIL, that we mentioned in the abstract, assessing uncertainty across all the steps in providing actionable climate information. That's a very good idea, but in between you have also the need for internal variability, parameter uncertainty, and model structural uncertainty that has to be quantified. And we'll come back and read underpinning technological infrastructure that we mentioned in the abstract, section 8. Section 9 is summary and recommendation for the way forward. Let's go back and read a bit more here in terms of the tables here. Examples of the main international projects contributing to the provision of simulations, data, and scientific knowledge to support climate policy, particularly IPCC assessment reports, including a main reference for each activity. CMIP and CORDEX are coordinated by the World Climate Research Program. So you have IAMC, Integrated Assessment Modeling Consortium, World Climate Research Program's coupled model intercomparison project, which is the last one is CMIP 6. We are gearing up for CMIP 7. Scenario MIP, where the scenarios themselves are compared using IAM and then feeding them into CMIP and CORDEX. CORDEX is the Coordinated Regional Downscaling, as I mentioned. VAX-AB is the Vulnerability Impacts and Adaptation, as well as Climate Services Advisory Board. And ISI-MIP is Intersectoral Impact Model Intercomparison Project. So global and regional impact modeling for multiple sectors there. ESGF is the Earth System Grid Federation. So that's data curation and distribution system for CMIP and CORDEX. So a lot of papers exist, and more papers will come as the new protocol is developed with the exercise that's going on right now. Okay, so this is how they imagine a schematic of how earlier rounds of integrated assessment models, comparison of coupled models, CORDEX, and impact modeling activities have worked together to develop and apply future socioeconomic and emission scenarios, increase the scientific understanding of how they improve the scientific understanding and ability to simulate the coupled Earth system model and investigate the impacts of Earth system change on societal and natural environment. Dark blue lines illustrate the main, generally two-way exchange of scientific knowledge between the different projects. So you have blue lines here, socioeconomic scenarios and global coupled modeling, regional modeling and impacts, and of course you have impacts to socioeconomic scenarios as well. And the others, this is for IPCC, policymakers and practitioners are sitting up there and getting all this information from everywhere, right? So dark blue lines, dotted green lines indicate the main simulation data transfer between projects. Those are shown here, and while gray lines show the main data exchanges outside of these projects. So here you are Earth System Grid Federation and other services that provide underpinning model and data distribution support. Global research community, which uses the output and cranks out a lot of papers and observations, reanalysis and model evaluation as well. Okay, so the feedback there happens. Finally, thick green lines illustrate the main knowledge and data exchange routes between the different projects, the global research community and the IPCC assessment process, as well as with multiple policymakers, practitioners and climate service providers around the world. Okay, so they have some points about how the better assessments should happen. Water, vegetation and biogeochemical cycles of carbon, nitrogen and phosphorus need to improve the estimates of vegetation change, terrestrial carbon uptake, regional water cycles and ecosystem tipping risks. Well, how do we do that? That's tricky. Is there some new thing they're offering to make this happen? Not necessarily. Improved assessment of future fire risk and interactions with carbon uptake, atmospheric composition and ecosystem tipping risks. So this is a European group. I think almost all are Europeans. Europeans obsess quite a bit with tipping points and tipping risks, whereas US and the rest of the world is not so obsessed with it. I am not obsessed with it because they are there. We are not really able to model them or predict them. So if the models produce them, we have to look at them carefully. But so far, nothing like that has happened. So pushing them and arguing that we are very close to them or we are closer than we imagined to the tipping points and so on are kind of distractions, considering all the other uncertainties and lack of information we have, lack of scales of information, etc. So I won't read all of these because they are just lots of such points that are rather obvious. Interplay between global change, regional climate variability, changes in climate and weather extremes, and resulting impacts across the Earth system. That's a motherhood statement, obviously important, right? So let's just jump to summary and recommendations for the way forward. I wanted to read this article basically because I am very curiously following what will happen with the setting up of the protocols, scenarios, simulations, synthesis for AR7, and my own argument is that there needs to be a cost-benefit analysis instead of continuing this exercise on and integrating out to 2100, knowing fully well that the information may not be, is very uncertain, unclear who's using it and how useful it is at the scales that it is being provided and so on. Okay, so summary and recommendations for the way forward. For the past 3 decades, internationally coordinated modeling projects have delivered a wealth of simulations, data and scientific knowledge to support policy actions addressing climate change mitigation and adaptation. And the clearest way to think is that we have taken them, we have negotiated for over 25 years, but the emissions keep going up. So we have to really sit down and think how well we are serving the needs. As a new round of these projects start up and the 7th IPCC assessment cycle begins, we have reviewed how these projects collectively have delivered science support to international climate policy. We propose a number of science, technology and collaboration priorities that we believe these projects should jointly focus on over the coming decade. Progress in these areas will increase the quality and utility of science support to climate policy, while also increasing our understanding of Earth system change, including the impacts on society and the natural world, as well as our ability to model such future changes and the associated impacts. One key proposal is for the involved modeling communities spanning integrated assessment, scenario generation, global and regional Earth system modeling, regional downscaling, and impacts modeling to work much more closely together during the next round of projects with an aim to deliver a coordinated set of scenarios, projections, and impact assessments, all based on the same underpinning socioeconomic and mitigation scenarios and using the most up-to-date model configurations. Very long and very motherhood kind of statements. Everything has to happen together. Of course it should, but how do you make it happen, and whether this is needed at all? Do we really need another set of scenario development and projections? That key question is not answered here. This will significantly improve the quality and consistency of scientific knowledge available to the upcoming AR7 and future IPCC assessments, as well as to the 5-yearly UNFCCC global stocktakes. Building on interactions developed over the past 5 to 10 years and proposals for simulations supporting international climate policy to become more operational in structure, the time is right to actively develop a tighter and more efficient set of links across relevant modeling projects. Why do we have so many modeling projects? Is it necessary? Does it give us redundancy, or does it give us more information? Realizing this ambition within the AR7 time frame is likely not possible, so themselves are admitting that the list is too long and it's not going to happen for the next assessment. Nevertheless, significant effort to achieve such internal consistency and efficient sharing of data, knowledge, and personnel will lead to future workflows better suited to fully realizing this ambition. Okay, we'll leave it there. I won't read the rest of it. Let's just jump to the end. Finally, to have one strong recommendation that that's the one key proposal. Finally, to expand the reach and benefits of international modeling, including the uptake and use of model simulations to a more global scale and thus deliver underpinning scientific support for global climate policy, there is an urgent need for increased involvement of Global South scientists. WCRP leads a number of important efforts in this area. These need to be ramped up significantly and put on a sound long-term footing. Given the global nature of the climate crisis, given the nature of the climate crisis, that the impacts are and will continue to be most strongly felt by the Global South countries, a globally inclusive response is a necessity. This makes both scientific sense to draw on local expertise for understanding and predicting local Earth system change and its impacts, and political sense, so climate policy is generally better tailored to a specific country's needs if it is based on local expert advice that is accessible over the long term. This is a group of European scientists, and the entire theme is very clear that it comes from a European perspective. And they encourage our governments and funding agencies to provide sufficient long-term support to further develop and maintain a strong and globally inclusive scientific collaboration over the coming decades. And this is also important now to consider in light of what US has done. Trump has pulled out of the IPCC assessments and so on. It's being done in a very ad hoc way, but it does require some thought on our side to global climate community to say, how do we become resilient to such political vagaries, and what exactly is needed to be done to minimize the efforts, financial resources, computational resources, human resources to keep producing these assessments every 7 years. What new things are being added, and how useful are the past assessments? What practically has been the use, especially of the data for 2100, the projections for 2080 to 2100. I think it's time to do a cost-benefit analysis and decide what would be the best and most useful and economically effective and efficient information for guiding climate policies, and be completely, or at least quite, immune to local political perturbations as a global entity. Okay, so I'll leave it there. My own comments, but you get the idea.